in the next panel, and the question will be, is the future all electric, and is it just electricity, or how does hydrogen plays a role? And I will be out of this now and hand over to Greta. Thanks a lot.
Sector coupling involves interconnecting energy-consuming sectors, such as heating and transport, with the power-producing sector. The demand for heat pumps, solar batteries, and electric vehicles is set to boom in the coming years by a factor of 5, 24, and 60, respectively. This will cause a corresponding rise in electricity demand, which must be met with increased renewable energy capacity and integration. This can improve the efficiency and flexibility of the energy system, as well as its reliability and adequacy. Sector coupling can also reduce the costs of decarbonisation. Today, most people rely on natural gas and mineral oil heating systems, and most forms of transport still rely on petrol or diesel fuel. But why is electrification so important? A device like a car being electric doesn't necessarily mean it is zero emission, as the electricity it uses can still come from dirty sources like coal. We need to first make sure that the devices that consume energy are capable of consuming clean energy. Once electrified, we need to swap out all of the dirty energy supply, such as coal, oil, and natural gas, for clean energy supply, like solar and wind. To enable this, our global grid needs a major rewrite to be able to match variable supply with increasing demand. Electricity could be used to produce hydrogen or synthetic gas, i.e. power to gas, to heat water, power to heat, and to power transport, or power to mobility. In fact, the German government considers the widespread use of renewable power, or power to X, the best way to decarbonise the country's economy, as it is widely considered to be the most energy-efficient solution. This, however, requires significant advances in the capacity and reliability of renewable power. Companies like Volkswagen are embracing this change. They established their own company, the Elli Group, which provides renewable energy and smart charging solutions in order to simplify the charging process for their customers and make the entire supply chain CO2 neutral. In this way, they aim to link mobility, energy, and digitalization to create an intelligent energy transition. Hydrogen is also emerging as a clean and versatile fuel with high potential for storing, moving, and delivering energy produced from renewable sources. In order to be clean, however, it must be produced from green energy. And barriers still remain in relation to hydrogen storage, purity, infrastructure, and safety. According to Siemens Energy, sector coupling via power to X has the potential to reduce primary fossil fuel energy consumption by 50%, even while power demand grows by 25%. Most actors agree that a mix of many technologies will be needed to decarbonise and interconnect different sectors. But the question remains on how to enable the creation of a truly sustainable and integrated energy system.
As we just saw, to ramp up the supply of renewable energy, previously separated sectors need to form links. For the next hour, we bring together professionals from heating, mobility, and electricity to discuss the challenges of sector coupling. Firstly, Ghanim Putrus is Professor of Electrical Power Engineering at Northumbria University in Newcastle in the UK. In more than 30 years of research, he has worked on over 200 publications, many focused on the integration of electric transport into the electrical grid. On top of this, he is an associate editor for Elsevier Renewable Energy Journal and serves on the editorial board for the World Electric Vehicle Journal. Welcome, Ghanim.
Thank you. Thank you for having me.
Thanks. We also have today Martin Möller, who's responsible for corporate development, strategy and business scaling at Westenergie, E.ON's largest subsidiary in Germany. Before this, he earned degrees in international management and economics, worked as a consultant in the energy space, and worked in strategy and business development at RWE and Energy, where he was responsible for international growth projects in Europe and Africa. Welcome, Martin.
Thank you. Happy to be here.
Good. We also have Niklas Schirmer, Head of New Business at Elli. He's responsible for future strategy, business development, and regulatory affairs at the interface of the energy and automotive value chain. Prior to joining Volkswagen, he was Director of Energy and Automotive at Berlin-based startup Ubitricity and worked as a management consultant in the renewables industry. He holds a PhD from ETH Zurich in mechanical engineering. Hi, Niklas. Thanks for joining.
Hi, and thanks for being here.
Great. And finally, we have Raoul Boya, who joined Viessman in June 2020 as Manager for Strategy and Business Operations. In this role, he manages Viessman's hydrogen strategy as the leader of the cross-functional project team. Prior to Viessman, Raoul worked as management consultant at Oliver Wyman for 5 years. He holds a master's degree in business administration and electrical engineering. Thank you for joining us as well, Raoul.
Thanks, I'm glad to be here.
Great. So let's dive straight into the questions. Ghanim, why is electrification so important, and how could it help to overcome current challenges facing both energy and transport?
Well, I think to answer this question, we need to understand the challenges first. What challenges are we facing? And then we can see the importance of integrating the two. As we all know, our energy and transport sectors, they rely on fossil fuel, and they contribute to a significant part of greenhouse gas emissions. Over probably 3/4 of greenhouse gas emissions from the overall energy sectors come from these sectors. So we need to tackle this, and to have the best impact is we need to tackle the electricity market first, the generation, and then we need to target transport, electrify the transport. Now, in doing so, if we take them individually, more renewable energy into the grid causes a problem for the grid. Basically, the grid is not designed to have too much renewable energy, which is intermittent generation. It's not central, it's distributed. It's largely uncontrollable. It relies on the wind and the sun. So the grid is not designed to deal with such type of generation, and having more and more renewable energy into the grid will cause serious problems to voltage, frequency control, and stability problems. On the other hand, looking at electric vehicles, electrifying the transport, we need chargers. We need chargers at home, at work, supermarkets, everywhere. Now, just to give you an example, if we have home charging, every charger is about, the smallest one is 3 kilowatt, and we may have 6 kilowatt chargers at home. Again, the grid was not designed for such type of loads. The grid was designed, the distribution network was designed to have houses with around average demand around 1.5 kilowatt. When you have 3 kilowatt and 6 kilowatt of chargers, this will overload the grid. The grid is not designed for this. So these are basically the two main challenges. Together also, we have also obviously the normal increase in energy consumption due to just the normal growth. And we have a demand for more energy efficiency. We have demand also on resilient grid to be able to go through natural events like storms and other things. So these are the challenges we are facing. Now, looking at the two together, we can convert these challenges into opportunities. So if we combine now the two, the energy sector and the transport sector, the renewable energy generation is intermittent, as I said, largely uncontrollable. If we bring storage from electric vehicles, and electric vehicles have high energy capacity, this can help control the grid. So when we are losing central control, we can create control through storage. We can have demand-side management. So we convert the philosophy of a grid control from controlling central generation into controlling distributed storage to meet the intermittent renewable energy generation. So we have here, when we combine them together, we can increase renewable energy generation without causing problems to the grid by using energy storage from the electric vehicles. All we need to do is to try to smart control both of them, so that, especially energy storage, EVs, so that we can charge when we have surplus of renewable energy generation and reduce charging when we have deficiency. And in this way, we can shift grid control philosophy, if you like, into dealing with both. And we integrate both of them to support each other.
And Niklas, what's your view in this? Do you have anything to add on what Ghanim said?
First of all, I totally agree with what you said, and we of course look at the opportunities there, but also into the needs. So Elli, or let's say Volkswagen Group charging, is of course in the need to secure all charging for all the millions of electric vehicles that we have very soon on the roads. And first of all, today it's the question that a car can be charged, but very soon it will be the question that the car will be intelligently charged, because we have these grid restrictions, and we see this large fleet of mobile storage as a big opportunity, actually, that we can bring to stabilize the grid and to better use the existing grid. So because everyone is talking about we need a lot of grid reinforcement. Yes, we might need that at certain points, but we will less need it if we charge very intelligently. And maybe as a second step, we of course are also talking about bidirectional charging. So it's not only smart charging, it's also giving back the energy to the grid. And that's maybe one point to add to Ghanim's story, that I see as the next game changer. Everyone is asking for storage and flexibility with the increase of renewable energies in the grid and in the energy system. And we will be able to let the cars discharge when there is no sun and no wind blowing.
And Raoul, what about the integration of heating in there as well?
Yes, so I mean, Ghanim mentioned before that we will have increased loads from electric vehicles of 3 to 6 kilowatts, but we will have the storage to actually compensate for that in some part. If we talk about heating, we definitely also can integrate that into the whole system. But at the same time, we will have generators that will consume electricity to a certain point. Also, in times of very cold weather, this can go up to 3 kilowatts per heat pump, for example, when we talk about electric heat generators. And considering this, we will have a significant increase of peak load to the electricity grid. And there we really need to think about how to actually optimize the overall energy system, not only sector by sector, but in combination of them.
Mm-hmm. And Martin, what's Westenergie's take on this, and how has the company adapted its strategy or business focus to account for the increasing integration?
I think our take on this is partially very in line with what I've just heard. I think there are interesting discussion points. For example, if I look at Niklas, I'm sure the two of us have different opinions on who should be responsible for organizing and orchestrating the charging process and the grid stabilization. At least I believe so, looking back at the past legislative period. Same or similar questions or open point regarding the heating. So Raoul already touched on it. It's not only about electric heating, it's about retrofitting gas-based heating. It's about the question how to integrate the different decentral energy devices we touched upon on one platform, and intelligently orchestrate this whole platform. But it's not only electric; there are gonna be chemical energy carriers still, and I think our take on it, or our business focus, as you asked, is to try to integrate all these different dimensions. In the end, it's the distribution grid, which is the physical, but also, I think in the future, the AI-based platform where all these comes together, and which again gives opportunities to any third party build up their applications on this platform and make use of the data and steering opportunities that come up with this integration. So how did we change? Well, we changed from a quite, I would say, easy one-trick pony thing, carrying electricity from one generator to one consumer, to a platform where we need to integrate all the aspects we're discussing right now, and yeah, that's an exciting task.
Thanks. There's many things we can take from that. Maybe we'll start with Niklas. Do you think you two would have different views of whose responsibility it is, or what is your take on that?
Well, I don't know whether there are so many different views actually, but it's more also the discussion on how to organize this system. And of course, there are from just role-based different approaches. So I'm in the luxury position that I'm, of course, not only looking into a German regulatory system, but also looking into other countries. And we see very good examples how flexibility markets are beginning to be designed in many countries, where we really have a flexibility demand and a flexibility offer, and these two demand and offer sides are connected with a nice price signal, and then we find an efficient and market-based way to move in a corridor that's still not critical to the grid. And then we narrow the corridor where we have really grid criticality and have the emergency stop situation that we will always need to have by the grid operators to really protect blackouts and other critical situations. So I think there's a lot to be done in market design, not only in single countries, but if you look into electric vehicles, that's European, if not a worldwide effort that has to be taken. Because we are in a very new situation for the entire energy market. On the first time, we have really users, consumers, and assets that are moving from one regulatory framework to the next. Because these batteries have wheels, these electric vehicles, and they are crossing borders. And if we want to organize that in a common sense, in a common fashion, then we really have to join forces on a European level, at least, to make a easy, usable, to make really easily usable access to the electric vehicles and the storage and the flex offer that we have. So, well, there are so many questions to be discussed in the regulatory framework. Why? There was no electric vehicle when the electricity framework, the regulatory framework, was designed. Simply nobody in the legislative room was thinking about electric vehicles. They were not thinking about mobile storage. They were not thinking about temporarily available storage and temporarily not available storage. So it's a complete system change. It's probably similar to the change that we had from the landline telephones to the mobile telephones. A complete system change. And there's a lot to be done, a lot to be discussed, and a lot of research to be done to really get this system running.
And you touched on batteries there, and we actually had a question from the audience asking, batteries have a limited lifetime, which is further reduced when they're used for grid stabilization. So how do you think we can handle this and better account for this?
I think I can take this question. There are two things happening. One thing is battery cost. Well, battery technology is improving, so we are seeing higher energy power density for batteries. Battery cost is coming down, and I think the figures I have in mind, published figures, in 2010, it was, I think, around $1,000 per kilowatt hour. Now it is around $200-300 per kilowatt hour. The expectation is that in the next few years and next couple of years, it will drop to $100 per kilowatt hour. So prices are coming down. And this means, the total cost, we call it, of ownership of the battery will continue to reduce and the electric vehicle. The other point I want to make also is battery degradation is physical, chemical process, and there are many factors that contribute to this. Some of the factors are the chemistry of the battery, the construction of the battery, which the user has no control on. But there are other factors. How do you use the battery is another main factor of the degradation. If we use it in the right way, we can minimize degradation. And this is where intelligent charging or smart charging comes in. If we use the battery in a smart way, we can reduce degradation significantly. And therefore, we can provide what we call electric vehicle for energy services, vehicle to grid or vehicle to home, in a cost-effective way with minimum degradation to the battery.
And in this realm of smart charging, and a lot of new technologies are emerging which are really important in this space. Which technologies do you think will be key in the transformation and operation of energy systems?
Well, I think there has a lot to be done in terms of metering technology, in terms of sensors and actors, to put it a little bit more abstract. Still, there's not enough knowledge, not enough digital knowledge about the grid situation. And I think we are moving into a new generation where we have much more knowledge what is locally happening. And then we can really run optimized business models around that.
Mm-hmm. Yeah, to add on this, and also on the question before around batteries, I think around batteries also the question is how do we account for that in a circular economy and with regards to sustainability. So for example, in the grid in Westenergie, we're currently designing a so-called CFIG, carbon footprint index for grid. And also for batteries, there's a question, which or whose scope is it? Is it the automotive industry's emission scope, the battery production and circular reuse, or is it ours if it's used for grid stability? Who takes responsibility for these batteries? As the person who asked the question rightly points out, when they are at one point to be replaced. Regarding technology, I want to underline what Niklas just said. I think on the physical assets, now looking at the grid, we have loads of the technology at hand which are needed for sector coupling. What we need and what we also need regulation for, I believe that we will cover that later in the next 40 minutes, is the opportunity to integrate intelligence into our system. And our system is the electricity, gas, or fiber grid, wherever we can. So we are actually able to decentrally steer all devices and make it a systemic effort to optimize it and come away from local optimas, which were in the past and likely also today, still the overwhelmingly happening.
Mm-hmm. And another question from the audience is, can you imagine a quartz-stabilized grid to control supply and demand with simple communication technology?
So a grid without people, basically? Is that what I heard?
Yeah, you can interpret that exactly, yeah.
Yeah, I can. I think it's a bit away. It's not in our grid, but I've spent some time in Greece, and 2 years ago with a large Greek distribution system operator, there were still projects going on digitizing paper grid maps. So actually have them digital for the first time, and that was 2019. So I would say we're a bit further in Germany, but for me, it's a big machine. this machine can be steered by sensoring solutions and AI, and this AI can be supplied with or can be steered without hardly any human action. That's very similar to the autonomous car, which we will probably at some point see also on our streets. It's a big effort. It's not this decade, I believe, but I strongly believe it's possible and it's going to happen.
Mm-hmm.
If I may just add to this, I think the electricity industry is used to what the philosophy called fit and forget. Until about 10, 20 years ago, I think it was difficult to convince power engineers to move into, using ICT or power electronics or, what we call now smart grid concept. But things are changing, and I think power industry has realized that we need to move into using technology has moved significantly, I think, whether it is ICT, power electronics, all sorts of technology, communication links, for example, mobile communication links. And the power sector was still trying to keep the system as it was. Rightly, I think they were saying, well, we have been working for 100 years, no problems, keep us going. But things are changing, I think, and we need to move into new technologies. And the new technology will help us, I think, keep the grid and the transport sector going to deal with the challenges we mentioned before.
And Raoul, what's your take on the role of new technology in the changing landscape?
Yeah, thanks a lot for the question. So, the theme of this whole panel is about, is the future going to be all electric? And our answer to that is clearly no. There is going to be a huge shift toward electrification, but being able to actually decarbonize in time will require additional technologies. And I believe one technology specifically in the heating sector that is not looked at enough are so-called hybrid heating devices, which are a combination of a conventional heating device, like, for example, a gas boiler, and an electric heating device, like, for example, a heat pump. And this combined system has various advantages. So it can run it can run cost optimal in an environment of variable energy prices. So we talked before about batteries that would be required to sort of deal with the shift of demand and supply in the electricity grid. But at the same time, you could use this hybrid heating device to do the same in the heating sector. And what we will likely see in the future is that we will have peak prices and base prices for the electricity. And if that happens, you could, for example, optimize your usage by using this hybrid heating device and run it once the price for electricity is low on the base price. And once the grid switches to the peak price, you could run it on gas. And this would have the effect that you would reduce your cost because you would be using less of the peak load price. And at the same time, you would be reducing the consumption of gas because most of the time the heat pump would be running. And this is, in my opinion, a very, very important technology for the future. And at the same time, if you make then the gas part of the system even ready for green gases like hydrogen, the system can even be totally carbon neutral. So in my opinion, it will be very important to have this technology in the portfolio of actually decarbonizing the full heating sector.
Mm-hmm. And Raoul, we've had a question from the audience. How could companies boost efficiency measures like household insulation to reduce consumption in the first place?
So if I understand the question correctly, it's more about the insulation of the buildings to reduce the heating demand overall. And well, that is a tricky question because it has been tried in the past decades throughout Europe and also in Germany, which is the market that I'm most familiar with. And the insulation rate or the renovation rate of buildings has remained quite stagnant, around 1% per year. And we see that there is low variability of that, even though incentives have been increased. And in my opinion, this is triggered by consumer behavior. Because if you imagine transforming your house, it costs about 100 to 150,000 euros to sort of refurbish the full house to make it energy efficient. And most people just don't have that money on their bank account. So it requires a lot of investment that has to be covered by a bank credit, for example. So you need that definitely. And then at the same time, so not looking at financials only, there is also a restriction on the available capacity of craftsmen. So again, for Germany, the utilization of this whole sector is almost at 90%. So there are just not enough people to do the actual refurbishment. And in my opinion, these two factors would have to be tackled specifically. And once we solve these, we can increase actual building insulation and improve or reduce the overall consumption of heating energy.
And looking more generally, Ghanim, how can we develop business models for energy services that benefit all stakeholders?
Difficult question, simply because there are too many stakeholders involved in the energy sector, in the transport sector, and when you start integrating these, you have to look at the interest of all these different stakeholders. There is complex interaction between them also. And usually their interest might be conflicting. Say, for example, if I own an electric vehicle and I want to contribute to the energy service, obviously the grid operator wants to maximize the benefit for the grid to support the grid control. But on my side, I'll be, losing on battery degradation, for example. So we need to develop business models that will look after all stakeholders, whether it is the energy supplier, the car owner, who might be different from the car driver. And these can have different conflicting interests also. So I think we have been involved in some work on this. And we try in a project, European project, and try to look into developing viable business models, if you like, to satisfy different stakeholders. And the only way we thought we could do it was to use multi-objective optimization, we call it. So we look into the objective of each stakeholder and see how we can maximize it. Obviously, whilst we are maximizing this, we are minimizing the benefit for other stakeholders. So we define these, for example, in using electric vehicle to provide energy services. And just to give you an example, one of the results we obtained was that by using electric vehicle to provide energy services, this grid operator can benefit, for example, by a factor of 40%, 50%. But this means a penalty for the EV user. EV user means they have to commit the vehicle, connected, ready to supply, accept some degradation to the battery, accept if you have got PV system that you may not be able to support your house if you want to support the grid. So if the grid operator is benefiting, for example, this 40%, then they can sacrifice 20% of this to give it as benefit to the electric vehicle owner or the house owner, so that they benefit also, and then we can have a win-win scenario. So I think the challenge will be, how do we develop all these business models in a complex system like this, and then moving to the next stage, which is advising policymakers on supporting these business models or creating the environment to develop these business models.
And may I add on this?
Yeah, of course.
Yeah, and I think the big challenge is to find the burning platform, so to say. So if I'm looking at the most famous example of trading electricity or trading energy in energy communities in Central Europe, I hardly see burning platforms for the people who could do it. I have done projects in Uganda and Zambia in rural areas where we wanted to build up electrical mini-grids to electrify these rural areas 2 years ago with energy. And then the burning platform is another. If you can earn significant money in comparison to your average income by trading electricity, you will also take into account, or you will also accept, that your storage system, for example, is degrading. Probably if you live in Munich, you wouldn't do that for €2 a month or 5 or even 10. So what's a burning platform? Why should people engage? And I think this is a big challenge. for everybody who tries to get into this system, because there are hardly problems for the people to be solved. One problem maybe comes up now mentally, that's sustainability. People become more and more aware, so that might be an angle. And then a second thought to Raoul, also underlining his thoughts about craftsmen and the availability. That's also a shout out to all the founders. I believe the gridX ecosystem is full of it. If you want to found a company right now, think about civil engineering. Niklas touched upon it for grid extension, grid enhancements. We do not even find enough civil engineering companies to do so. So we do not have any other option but applying intelligence in order to orchestrate these challenges and the grid, stabilize the grid, because we will not be able to dig up the ground to bring in more copper.
Yeah, and then if I may add also one point to it, I think it's really a question of market design, because market design enables business models. I think in the past there was a lot of discussions from the regulatory side how to design the business models, but for me the question should rather be what framework, what market design should be established to let the business model develop themselves. And I think that would be the step forward. And Martin, you were mentioning the intelligence in the grid. I think we need mechanisms that really support these intelligence, this digitization of the grid, also on the financial side, because today it's not so attractive for these large asset owners as the grid operators to really still not invest enough into intelligence and digitization, because it's simply from, again, market design and regulatory framework perspectives, not financially attractive. And this is something I think we can really change quickly, and this will be the game changer.
Mm-hmm. We've had another question from the audience, which I'll direct to Raoul. Isn't power to gas a good option to couple sectors, particularly in the sense of reusing existing infrastructure?
So power to gas is definitely one of the technologies that will help us to decarbonize in many sectors. Then again, we will have to be realistic on the amount of energy that is needed and where it is needed, and the amount of electricity that we will be able to generate in certain places. So the point that I'm trying to make is that in certain areas, especially in the European Union and in some countries, we definitely are going to need imports, because sort of the heating sector consumes about 1/3 of the overall energy. If you compare the full range of sectors, and if you even include the high temperature processes, so the process heat, it rises over 50%. And looking at that, we would need to increase our electricity generation so manifold that we will probably not be able to do it all within the European Union. So imports will play a role. There are certain regions throughout the world that are able to generate enough electricity and then convert it to gas that can then be transported. Gas is an energy carrier, so to say, that can then be transported and imported to the regions that are not able to generate enough electricity for the full energy that is being consumed.
Mm-hmm. And with this in mind, Martin, what do you think will be the major challenges in the future in terms of balancing everything, ensuring a competitive but regulated market?
Yeah. There are hundreds of challenges, right? I think Raoul just touched upon it. Let's just take the energy consumption as such. Even though I'm looking just at a slide here with loads of studies until 2050, even though our energy consumption in total until 2050 might decline, even according to some studies, up to a decline of up to 50%, the emission-free energy society. That's so far away, and we will have imports on an economic level. The question is, how do we import? So I do not see, and that's also why we didn't have success with the Desert Tech initiative. So we had the plans as Europe, let's say, to import electricity through big cables from Morocco, more or less. It didn't work. It doesn't pay off. And now similar questions or similar ideas arise around hydrogen. But there are no solutions in shipping to bring actually these amounts of hydrogen from where they would be produced, be it ammonia or hydrogen itself, to the big industrial clusters like the Ruhrgebiet in Germany. We don't have the shipping solutions. Will we have trucks to transport it? If we have trucks, do they go on diesel? Niklas will answer that, I'm sure. I don't hope that they go by diesel. If it comes from Australia, will it be like heavy oil ships? So on an economic level, there are so many questions to be solved. On a, let's say, little smaller level, we have not only the sector coupling between the sectors we are now discussing, but we also have the question of data infrastructure. So how is data infrastructure being added to this whole game? Fiber grids, radio towers, data centers. How will data centers be fueled? They are suddenly exploding in terms of energy consumption. We touched upon heat, we touched upon hydrogen, but what about water? Also water itself. So water is also becoming more and more part of the energy thinking, I would say, and of the sustainability thinking. I think we're looking into another drought summer in Germany. I think we have a systemic issue we need to solve where little things are in balance, I would say. And most of these challenges, they will be felt in our distribution grids, which then brings us down to digitization, to connectivity, but then it brings us to cybersecurity. So if we do all these intelligent design, how are we ensuring security? Because I think Ghanim touched upon it. The engineers who built our grids 2 decades ago, sometimes 8 decades ago, they're not exactly cyber security experts. So our industry, I believe with Volkswagen and Viessman, it's similar. They're not necessarily used to this playing field. I could go on for a few minutes. I will stop here. But you see the amount of challenges, let's say on a business level, on a macroeconomic level, on a regulatory level, on a sustainability level with regards to nature, they're enormous. And that's why this panel is put great together, because only with academia, with a heating industry, with mobility industry, with energy industry, with some other industries like steel, we can tackle these challenges together.
There's a lot of information there, a lot of challenges, as we can see. Let's focus first on diesel. Niklas, what do you think will be the role of diesel in the future?
Well, if I talk about Volkswagen, we have a very clear electrification roadmap. I think our commitment is very visible, and some people out there also call it aggressive. So there will be an all-electric future. I mean, if you're watching just the Euro 2020 and you see all the advertisement by Volkswagen, I think the message is clear. There is in passenger transport, there will be an all-electric roadmap for sure everywhere in the world. So let's look really into the future at that point.
And Raoul, what do you think about the challenges of transporting hydrogen?
Well, I mean, we mentioned it already, so Martin touched on it, that there are still technologies to be found or to be proven that they actually work to be able to transport hydrogen across large-scale distances. And what we didn't mention is that there are also pipelines that you could use. So it's the same for natural gas. You can even retrofit existing natural gas pipelines and use them. And for certain distances, even long distances, this is even cheaper than transporting it by ship. So this shouldn't be forgotten. And you would also it would also be easier because you wouldn't have to sort of transform the hydrogen into another chemical and then retransform it. You wouldn't lose that much energy when transporting. So I believe we should add the pipeline transport to the list that we already described before.
Mm-hmm. And going back now to regulation, we've mentioned that it's pretty outdated. Ghanim, how do you think regulation can be improved to take into account all of these different challenges?
Yeah, as I mentioned before, we were involved in a European project. We just finished it a few months ago. We looked into regulations, business models, and so on. One of the areas we looked at was energy plans in Europe, transport plans, and we found these were largely separated. So municipalities will have action plans to deal with electricity or energy sector. They will have different plan to deal with the transport sector. And we are trying to push hard to try to combine these two, to try to integrate the plans for the two, because you can't solve the problems. You can't regulate or plan one sector on its own without the other. The way technology is moving towards integration. And therefore, we published, we called it policy recommendations, really, a flyer, but also a report on policy recommendations, how we can integrate these two. We looked into current policies, legislations, and then we gave some advice on the need, really, to integrate these two and how we can move from, we call them urban mobility plans, urban energy plans, into urban mobility and energy plans, integrated plans. I think that will be very important for the development of the integration of the two sectors.
Mm-hmm. And as you mentioned, it's obviously really difficult to integrate the regulation when they have different variables. For example, if some sectors have an emissions trading scheme and some don't, how can we take those sorts of differences into account?
Yeah, well, we had councils, local councils, and municipalities in the project also involved. And I think part of the solution, if you like, is getting these on board to understand the need for the integration and how these will help their plans to reach decarbonizing the energy sector, decarbonizing cities, and so on. So I think getting them to understand the difficulties they have and the solutions available, if you like, to deal with these difficulties was, major part of the work.
And Niklas, what's your take on these regulatory challenges?
Well, I mean, I already stated in the beginning that I see a lot of regulatory changes that we have to make. I would say we have to do it in a European fashion. So really let it be steered by Brussels. And what we also need is we need an evidence-based framework approach. I come back to the discussion about CO2 and also about hydrogen. If I follow the discussion, a lot of discussion is very emotionally made, and it's also steered from certain lobby groups. I think if we come down and really take the numbers and really look into cost positions and really look into really the need and the commitment to the Paris Climate Agreement, what needs to be done to really get there, then we would have a different discussion. And then we would rather focus our discussion rather looking into solutions than only looking into today's fighting of different views on the system. So that's not so much about regulatory, that's more about the general approach to it. But if it comes to regulatory, there we need the big regulatory deal. We need, if I talk about electric vehicles, we need the big regulatory deal for vehicle to grid, for bidirectional charging. there's a lot of empty spaces there. I see the stationary storage industry also having a lot of challenges to really integrate decentralized storage into the energy system. And this industry has similar hurdles to be overtaken than the bidirectional charging industry that is evolving. So I would suggest really to join forces and make a new approach, and do not just incrementally change the existing system. Sometimes I would suggest we really need a big new approach.
Mm. And in line with this, there's obviously a lot of urgency around the energy transition in order to reduce our carbon emissions. Martin, how do you think we can overcome these challenges and reduce our emissions within the necessary timescale?
I think the easy answer is that we need to be pragmatic. So that goes a bit into the direction of what I've just heard from Niklas. A big problem from my point of view are groups of interest. Of course, everybody in such a transformation needs to see where his profits goes, where his position is. However, we can overcome these challenges if we are pragmatic, if we agree that the final goal, the final destiny of being emission-free is actually our goal, and that it's not that not different groups are following intermediate goals like establishing hydrogen, or only establishing the all-electric world, or being sure that steel industry stays in North Westphalia. These are, of course, all legitimate goals, which I can fully understand. And as head of strategy of a distribution grid company, I also have my intermediate goals. However, we need to agree on the final goal, and we need to be pragmatic, accept an energy mix that is green, and be, usually you say, technology agnostic. In that setting, I would say we need some kind of energy carrier agnostic, as long as this energy that is used is actually emission-free, no matter where it comes from. We need also to be realistic. We cannot, I think we shouldn't waste time by running after ghosts. Again, the desert tech example, I think that was for a long time, at least in the energy industry, a big, very attractive thing to believe in. So it would have solved all the renewable energy solutions in Europe. Oh, surprise, doesn't work. And I think there's some of these, I would say, fantasies in the room which might be followed, but which shouldn't be followed. That's a long answer to basically saying, let's be pragmatic. Let's use what works at the moment. Let's also accept the one or the other intermediate solution in terms of different colors of hydrogen, for example. Let's come there step by step, and let's start, because if nobody starts, there will be no scaling. If there's no scaling, there's no price reduction in different emission-free energy carriers, and if there's no price reduction, there will be no market, and we won't get anywhere. And of course, I'm fully with Niklas. To make these possible, we need a transformation of the regulatory framework in different areas that incentivizes companies, but also individuals, to start building this market. If we don't have that, we humans are very simple. I believe we stay with what we know and take the easy way, and then we will not even arrive at these challenges, far away from mastering these challenges.
And Raoul, do you agree with this?
Yes, definitely. I mean, the first and foremost important thing is to leverage the full range of options that we have in the solution space. And the challenge of decarbonization is huge, as we've discussed, and it goes for every sector. And so in my opinion, prioritizing one sector over other sectors, or even excluding certain technologies from sectors, will only reduce the probability of us being successful. So if I could ask for one thing, it would be to sort of stop talking about the heating sector and the heat pump and go a bit more into the details with the analysis to better understand the dynamics of the actual heating sector. Because to me, it always sounds a bit like you have this black box and you put this one tool in the black box and suddenly all of the problems are solved. And at the same time, we have the option to make the heating sector ready for hydrogen. And yes, at the same time, we can try to go as electric as possible. But once we realize that electrification will not take us the full way towards our objectives, we still have the option to simply flip the switch and decarbonize the remaining bit using carbon neutral green gases. And I just love the idea of, or the beauty of this idea and how it goes well with the other options, the other technologies that we have. And as I described before, we have this hybrid solution, for example, and I would really love to see this in practice and bring us towards our objectives.
And just going a bit deeper into that, why can't electricity take us all the way? What are its limitations? Why do we need complementary and chemical energy carriers and hydrogen?
So we mentioned before that we have drastic challenges, like, for example, the grid stability, the backup capacity when there is in deep winter times or in sharp winter times when there is cold weather and we have high demand for several weeks, that we have to overcome these gaps, for example. So this is one aspect of it. And I do not say that it's impossible. It's just we have a difficulty to getting there in time. We have this target 2050 for most countries. In Germany recently, even 2045. That's not so far away. So actually being able to transform in that time span is a huge challenge. And we believe that we can get there more easily by integrating green gases like hydrogen in the heating sector. And at the same time, it will even optimize overall system efficiency. And in my opinion, this should be the main KPI to track if we are effective, while at the same time, of course, adhering to these objectives that we have set ourselves.
We've had a question from the audience of the role that software will play now and in the future.
Is it directed to the heating sector or is it an open question?
It's an open question.
Well, if I may start anyway. As Viessman, for example, we have a portfolio that we like to describe as an offering stack. So we have the base layer of all the products and systems, obviously, the heating devices, the air conditioning, and so on. And then on top of that, we build platforms and connectivity. So there the software starts. And then we build services on these platforms and the connectivity. And these can then even be value-added services that end users or partners like installers that install the devices in homes can then use to actually create value from it. So the connectivity and the software will play a major role in the future. And we are already tackling this quite actively in our portfolio.
And Niklas?
Yeah, so software is definitely the game changer here. We, of course, have the infrastructure, as we were talking about the grid. We still need more intelligent infrastructure, also on the hardware side. And then we will have business models that are hardware bundled service business models. And software makes a difference. And that's really the delta that we have to look into. So I would say if I would talk about the future, this is all a software and data game. And the hardware side, that's all to be solved, all already, in many cases already solved. Of course, we will need some changes and developments in power electronics and communication technologies. But in the end, even this is software.
Mm-hmm. Just to add to what Martin said Niklas, this is a very important point, really, because the way the sector is moving, whether energy or the transport sector, is more into user participation, and user participation requires software. So software will be enabler, I think, whether it is the EV driver charging or contributing to energy services, or whether it is energy user at home contributing to providing energy services or local energy management and so on. So software will play an important role, I think, in this.
Mm-hmm. And one final question from the audience directed towards Martin. What are some of the challenges you faced in the development of standalone microgrids in Africa?
Some of the challenges. I think the largest challenge is to be brave and go there, coming from our markets. Once you are there, I did experience that we were very welcome, that our concept was very welcome, that we got meetings with high officials in the government straight away, that the people in the villages who we presented the opportunity to were very interested. On a conceptual level, the problem is the hen-egg problem. So there are many great solutions in the market to bring electricity anywhere, basically. I mean, it's easy with PV, but you need industry in a way. So if there's no electricity, there's no industry. If there's no industry, you don't have any off-takers for your electricity because television and fridges don't do the trick. So you need some kind of industry there, and you need to integrate this thinking, bring both at the same time, and thereby doing so, thinking more about a societal development program rather than bringing a energy solution. You need to raise demand and supply at the same time. And most companies are not used to do so. Either they need electricity because they want to build something, create something, or they supply electricity because they're an energy company. But you need to do both at the same time, alone or with a partner. Then there's golden soil to do so. 700 million people without energy, great market. And I would say this conceptual thing was the biggest challenge, actually.
We could definitely talk about this for hours, but unfortunately we've run out of time for today. Thank you so much for coming and having this really fruitful discussion. I think, as you mentioned, it was really good to bring people from different sectors together, and I'm looking forward to our integrated future.
Thank you.
Thank you very much.